Yes.
I would like to ask again. Let's say that we have like as you did, we would like to run like 50 configurations, right? And how to set up the second 5,000 run, 5,000 step. Do we start from the last configuration from the last confirmation from the first 50,000 steps?
Yes, we have to continue from the last step I, then step I plus 1. In the step I plus 1, need information from the step I. What kind of information it needs? So the information it needs is the coordinates. Okay, the coordinates of the last step, coordinates, and also the velocity. You see that this is coordinate and this is velocity. So the next line will take the velocities and the coordinates to continue. So you have particles move it as a function of time, continues in a single trajectory. That's a good question, and I will show you again how to do that. Show you there's so many files here. Let's say 29 configuration file. See that input file. Now I take information from the previous step, which is MD28. Okay, and generate output to MD29. What file I take it? So it's here. Now this if section is now active because I put 1, and it used the restart coordinate file and velocity file from this. This is variable input name. Variable input name is defined here. So it's a MD28. All right. Okay, I just let the run and wait for the result. This is one more thing. After we run the simulation, the file, it generate a lot of output file, and when we do trajectory analysis, the file that we use has an extension called .dcd. Okay, remember, these files contain the trajectory of your system. So mostly the analysis will read or extract information from this DCD file. After we have a trajectory, we extract some dynamic properties from the system. For example, calculate root mean square displacement or IMSD. We might be interested in the distance between a particular atom or particular residues. We analyze hydrogen bond, or we want to know the solvation structures of the system by plotting the radial pair distribution function. Maybe we want to know about the shape of the molecule by calculating the radius of gyrations, or solvent accessible surface area, and so many properties depend on what kind of analysis. Actually, we don't need to write a new program. There is a command available and a script also. We don't need to write from the scratch. We can find this type of script on the internet, but you download the script. You have to modify and then modify according to your system. Okay, about this is the TCL script. We will do it later. Let's wait when we get the trajectory. This is an IMSD plot. This is solvation RDF.